Welcome back, students. We are now down to the topic 2 of GE114 Satellite Geodesy. In this topic, we are going to discuss all about the review of relevant concepts for satellite geodesy. This is for the authors and contributors about this material, and this is for the copyright notice. For the outline of the presentation, we have 3 parts. First is the part 1 is the reference systems and frames. Part 2 is the ellipsoids, geoid, and geodetic datum. And lastly, for part 3 is the transformation of horizontal geodetic datum. This will be the intended learning outcomes that after this lecture and exercises, you, the student, must have first is explain and discuss the concepts and properties of different reference coordinate systems, identify and discuss the reference coordinate systems and frames used in satellite geodesy. Next is differentiate and illustrate the ellipsoid, geoid, and geodetic datum. Perform computations in the transformation of horizontal geodetic datum. So let's start with the part 1 about reference systems and reference frames. When we say reference system, it is a conceptual or complete conceptual definition on how a coordinate system is being formed. It defines the origin of the orientation of fundamental planes and axes in the system, and this also includes the underlying fundamental and mathematical physical models. So class, when we say reference system, it's more on theoretical nga side, no? It's because conceptual nga, di ba? The concept of how the system is being formulated. Kumbaga, later on nato man i-discuss no kung say analogy between the reference system and reference frames. So technically speaking, or basically, the reference system is just the theoretical concept or the overall conceptual, no, nga definition kung unsaon siya, di ba? Kung magbuhatag isa ka butang, no, or somewhat like natay buhaton na project, so we need to conceptualize first of what is to be happen, no, say mahitabo nga pag-atuan ning i-pursue na project, let's say project, no. So it's more on the conceptualizing na, no, sa inyong gihunahuna, and more on the theoretical side. That's the reference system. And when we say reference system, it is unattached, no, to the real world. It's because concept pa man siya, no? And speaking of reference frame, this is the practical realization of a reference system through observations, and it realizes the reference system by means of coordinates of definite points that are accessible directly by occupation or observation. It consists of a set of identifiable fiducial points on the sky, for example, stars and quasars, or on a Earth surface. Example is the fundamental stations. And in practical surveying, we are only concerned with the reference frame, but underlying concepts of a specific reference frame are fundamental importance. So when we say reference frame, this is now the realization of the concept that you are going to nga inyong giplan or inyong gihuna-huna during the formulation of the project, for example, no? So one simple analogy is that ingani si reference si reference system is the prescription or kung gintahay na masakit sa inyong family, let's say sa inyong family or inyong loved ones, no? So the reference system is the prescription of the doctor. So nanay findings sa doctor nga, let's say for example nagka-UTI, no? So nanay findings, then naay prescription ihatag si doctor sa inyo, ha? For example, hatagan mo niya og reseta about the tablets and all the necessary nga tambal, no, nga ihatag or reseta sa inyo, ha. So kung ato siyang i-connect into reference system and reference frame, kanang reseta nga inyo nadawat from the doctor is now the reference systems. So it's a prescription, no? Dili na nimo ma-realize unless dili nimo siya paliton, no? Kay anyway, it's a prescription for you, no? Nara sa imo kung gusto nimo maayo, then paliton nimo na siya nga tambal. So ang tambal nga pagpadton niyo sa pharmacy, ang tambal nga inyong gipalit is mo na siya ang realization, which is kung ato siyang compare sa reference system and frames, so ang tambal is now the reference frames, no? Kay inyo man siyang gi take into reality na, no, nga, from the prescription, which is a conceptual one, then gipalit ninyo ang tambal, no, which is now the realizations. Same as this in reference systems and reference frames, no? So nagingon diri in practical surveying, we are only concerned with the reference frames. Of course, kaya kanang reference frames class is muna na siya tong makita, no? Like for example, mga muhon, no? That's the realization of how the system of reference is being formulated. Mga muhon, mga BBMs, benchmarks, so may lain, GCPs. So that's the realization of the reference systems. Same as atong gihatag nga analogy kaganina, no, nga, useless ang imuhang prescription kung dili nimo siya paliton, kay dili makamaayo kung dili ka mo inom og tambal. So pareha sa gyapon sa reference system and frames, useless lang ang imuhang reference systems kung walay reference frames nga, which is ang realization, no? So ingana, no? So and vice versa siya. Again, sa reference, baliwala gyapon sa reference frames, which is ang realization. Okay. Kung wala ka, kung naa kay mga reference frames such as mga muhon, pero wala kay system, no? Wala kay gibasihan nga system. Therefore, ang imuhang reference frames is mura siya wala, no? Kay wala man siya gibasihan. So vice versa, importante ni silang duha sa reference system and reference frame. So another analogy class for reference system and versus reference frame is this one, chess mat o si chess pieces. Analogy is, without a reference frame, the coordinates of the control points are like chess pieces without a chessboard. So maya kung ganina, useless lang, no, useless lang ang reference frame kung wala kay gibasihan na system, which is ang reference system. According to this one, they can be arranged, analyzed, and moved about, but they have no meaning. No? So, sige, mura ka, imagine na class, mag-chess ka tapos walay chess mat. So, nalagi kayo mga chess pieces. No? Pero unsa ni mo pag-move? No? Or, sige, maiswag man mo siya, mag-move mo into another directions. But, for what purpose? No? Di na siya matawag nga chess kung walay chess mat. No? Same as sa reference system o sa reference frame. Na kay mga reference frame, na kay mga muhon, pero wala kay reference system. So, floating or murag lutaw ang imuhang mga muhon. Okay? Wala makakabalo. Mura kag galakaw nga, wala kay padulungan. No? So, gabuhat ka o mga muhon, ga-establish kag mga muhon, pero, walay system. No? Walay sistema. Useless lagi hapon siya. So, as, kung na kay chess mat, tapos wala kay chess pieces, no? So, mura siya yapon wala, di siya matawag nga dula nga chess kung wala siya chess pieces. Unless otherwise sa inyo ga man jud mo no ga modified, resourceful ba yata bisan todo og wala tay chess pieces, himo na to ang tansan, no? Pero dili siya suitable na, no? Kay ang pag moingon ta og chess nga dula, so naagid na chess pieces, so apoy chess mat. So again, ingan ang reference system and reference frame, they are both useless, no, kung dili sila ang magpartner. No? So let's go now to the celestial reference system class. Ultimately, the orientation of the terrestrial reference system is tied to an astronomic system, as it has always been throughout the history. So it is also called as inertial reference system. So celestial reference system is also called inertial reference system. It is in which our laws of physics hold without requiring corrections for rotations, and for geodetic purposes, it serves as the primal reference for positioning since it has no dynamics. So sa unang panahon class, wala pa na naimbento ng mga GNSS, mga bagong technology karon na we are using satellites. So ang system nga ilang ginagamit or ang ilang ginabasihan sa pag-calculate or pag-locate sa isa ka position is ang celestial, no? When we say celestial is the heavenly bodies like stars, no? Quasars, moon, no? So naka-remember mo sa unang panahon, no? Like for example kanang how the three kings no locate that asa si Jesus no na tao. It's because they are using the stars as their guide no. So ingan na ang ingan na lang ang murag simple analogy ba nga makaingon ta sa unang panahon nga ang ilahang basis for locating points on the surface of the earth is just the stars no and other heavenly bodies nga pwede nila mahimong bases. So sa unang panahon mo na ilang ginagamit and diba sa Moana pod no they are using their palms no kung unsa nakatas-on from the horizon ang isa ka star no? It means to say na sila timailhan no kung isa ka palm or duha ka palm or duha ka palad nila ilang isumpay. So mga nga mga determination no, of locating the points. So that's the celestial reference system. Another one is the problem was their accessibility and hence the reliability of the frame no. Ay since murag hint lang man jud nila no dili siya necessary na locate pero makalocate man sila but ang next na pud na question is how reliable is that. So next is the very long baseline interferometry or the VLBI measurements of these quasars has prompted the redemption of the celestial reference systems. So niabot na ni si very long baseline interferometry which is it is the measurement of the stars and quasars no from the surface of the earth and this prompted no the redefinition of the celestial reference system. Ay since sa una kay murag hint lang Manila but now we have this they have this technique of measurement which is the very long baseline interferometry nga ni bag-o sa ilang pananaw no on how to calculate the location in the earth. In this way, the definition has fundamentally changed the celestial reference system from dynamic system to a kinematic system. So let's go to the International Celestial Reference System or ICRS. It is defined to be the inertial system, like for example, non-rotating, whose first and third mutually orthogonal coordinate axes or the equinox and pole are realized by coordinates of 608 compact extragalactic sources or the quasars as chosen by the group of reference system of the International Astronomical Union or IAU. Then the realization for the ICRS of course is the International Celestial Reference Frame or ICRF. It is accomplished with this measurement method or technique of measurement which is the VLBI or the very long baseline interferometry measurements of the quasars. And as observation improve the orientation of the ICRF will be adjusted so that it has no net rotation with respect to the previous realizations. The accuracy of the celestial reference systems was affected by these following parameters. First is the dynamics of pole, which is the precision and rotation. Or we have also observational systematic effects such as proper motion, aberration, parallax, and refractions. So since kay kinematic naman ang reference system, ang celestial reference system, kay it's because we all know nga ang Earth is rotating, no? Earth is moving, Earth is revolving around the sun. So therefore na mga movements. So mao ni sila ang naka-affect, no? Naka-apekto sa accuracy sa celestial reference system. So itong isa-isahon, when we say precision, it's the Earth. If the Earth is not a perfect homogeneous sphere, no? We all know that. Nga dili jud siya perfect sphere sa Earth. So naa siya flattening and also naa siya bulges around the equator. Its rotation is affected likewise by the gravitational actions of the bodies in the solar system. Okay, since we have those gravitational attraction between the celestial objects and heavenly bodies in the outer space. When we say precision, it is a change in orientation of rotational axis of a rotating body. So I guess ako na nag-discuss or ako na siyang gi-introduce ang precision from our previous discussion or the topic 1. In an appropriate reference frame, it can be defined as the change of the first Euler angle, whereas the third Euler angle defines the rotation itself. this is the illustration of the precession na ay changes sa iyahang orientation. For example, diri ang first na axis, no, kay which is ang ato amang north star karon is Polaris, no? So due time, this is 26,000 years, or after 26,000 years ga-change na siya, no, ang iyahang orientation, no? And like they said, after the 26,000 years rather, dili na si Polaris atong North Star. So maabot na daw ang panahon niya si Vega na ato ang North Star. Dili na siya si Polaris. So right, another illustration for precision. It's merely the change in orientation. So after 26,000 years, ang pag-change og iyang orientation. And let's go now to the nutation. Nutation are due primarily to the lunar solar attractions, and hence can be modeled as basis of geophysical model of the Earth and its motions in space relative to the Sun and Moon. Another term is the rocking, swaying, and nodding motion of the Earth's axis of rotation, and is largely axially symmetric objects such as gyroscope, planet, or bullet in flight, or an intended behavior of a mechanism. So ang link for ani niya class is kaning si rocking, swaying, and nodding motion. So naa siya mura og vibrations, no. So samtang ga change ang orientation ni Earth, ang change ang orientation ni Earth, naa pud siya vibrations nga mahitabo samtang nagtuyok siya, no? So this one, no, this is the rotation kaning part, no? Ga-rotate si Earth diha. Tapos na siya vibrations nga murag inganing forma. Anong mura siya og sinusoidal ba, or ay na lang. Right nga term is mura siya og wave, no. Anong wave iyahang murag motions, no? Or literally ga-vibrate lang, no. Ga-vibrate siya, ganyan na siya forma. And precision is ang katong pag-change in orientation. Nutation is this one, kaning red, no? Subay siya ana nga path. Kaning R is rotation, P is for precision, and the red is the nutation. Another one is kanina rotation. These are the movement of the Earth sa iyahang own axis. Then as the Earth is doing the precision, which is the changing in direction, ga-rotate, move yapon siya. Ang kanang movement sa path sa precision is what we call nutation. Next is the proper motions. When we say proper motion, it refers to the actual motion of celestial objects, no? So take note of this one, celestial objects, or the actual motion of the celestial objects with respect to the inertial space. And it is also known as the space motion and stellar motion. It can be decomposed into motion of the celestial sphere, which is the tangential motion and radial motion. So we all know that the Earth is moving, right? So also the celestial objects such as the stars, the quasars are also moving. So kung naatay mga reference ng mga heavenly bodies like stars, so let us all take note nga they have their own system, no? Kung naa sila system, naapoy motion nga mahitabo. Di lang nato siya ma-determine or di nato siya ma-differentiate itungod na sa ihang kalayon, no, with respect to our planet Earth. So this is the proper motion. So this is the illustration, no? Like for example, that one, kung mao ni si star, mao ni atong the Earth, no? So instead na from the center of the Earth padulong sa star, so supposedly is mao na siya ang mura og essential, no? It's because tungod sa kalayon, di ba, di naman mag-matter kung unsay forma or unsay exact shape anang stars, or even ato ang planet, no? Kung tan-awon po nato sa outer space, si planet is labi na kung magkalayo na ta sa tuang system or solar system, So point na lang siya, no, sa ato ang sky. So as the star, with respect to our planet Earth, atong makita is point na lang siya tungod sa iyang kalayon. So instead of directly to the center of the Earth, padulong sa stars, so naatay kanang changes, no? Like for example, mao ni ang ato ang point, no? Or diri ta nag observe, no, at the certain part of the Earth, no, diri. So naa siya change, no, or naa siya differences. So that's what also mo na siya ipasabot kung unsa ang proper motion. Next is the aberration. So when we say aberration, it is the displacement of the apparent object from its true position on the celestial sphere due to the velocity of the observer. So in karon na pod nga part is with respect na pod sa observer, no, due to its velocity. So we all know nga the Earth is moving, the Earth is rotating, the Earth is revolving, plus na pag nutation, plus na pag precision, so dakay makaapekto. So mao nang naay changes gihapon, no, sa naay displacement of observing the celestial objects with respect sa observer, which is ang observer is also moving kita, no, ga-move ta kay naay rotation, tapos na apoy revolution and other motions, no, sa Earth. So aberrations due to the observer or velocity of the observer, kay di makabantay mo when you are going to observe stars at night. So sa inyo makita murag ang star may move, no, so pero dili na siya mao ang fact, no. It's because mas paspas ang ato ang motions, mao nang makita nato ang hala. Like for example, nag-observe ka og stars at 8 PM. Tapos pag along na sa mga around 12 midnight, nalahi na ang iyang position. So it's because naay displacement kinahitabo kay kita nga observer na ata sa isa ka object or sa isa ka celestial body nga ga-move or ga-rotate. So ingana siya. The classical analogy is the apparent slanted direction of the vertically falling rain as viewed from the moving vehicle. The faster the vehicle, the more slanted the apparent direction of the falling rain. So ingana ang iyahang analogy, no? Like kung magsakay mo og motor or kamoy mag-drive mo og motor tapos taligsik or let's say ulan. So samtang magkakusog ang imong dagan, makita nimo nga ang droplets sa ulan is nagkaslant, no? Nagkaslant siya. So kung hinay mo yung padagan, dili pud kaayo slant ang droplets sa rain. Or let's say for example, sakay mo bus, no, naa mo sa front seat na part. So makita ninyo nga kung kusog ang dagan sa or dili na sa front seat, like for example naa mo sa window kilid, no. So sa inyo makita, no, samtang nagkusog ang dagan sa bus, ang droplets sa ulan makita niyo magabi ka slanting, no. Pero pag hinay or let's say for example naka-steady lang, so nice slanting pero dili kaayo siya ingon nga dili kay siya ingato kaslan kung kusog ang dagan. So that's the analogy for aberrations, no, like this one, no? For aberrations, there is a true direction of the light source which is from the sun, because there mo ni siyang apparent direction of the light source, no? And this is with respect to the velocity of the observer. So kung magkakusog ang velocity sa observer, mag-change ang iyahang light direction. So that's for aberrations. So for aberration, we have kinds. First is the diurnal aberration. This is due to the observer's velocity associated with the Earth's rotation. Diurnal with respect to the observer's velocity. Next is we have annual aberration, or diurnal aberration pala class is observer's velocity with respect to the Earth's rotation. Okay, since diurnal, one day man na siya. So, one Earth rotation is one day. Mo na siyang diurnal ang tawag. Next is annual, due to the observer's velocity associated with the Earth's orbital motion. Again, observer's velocity associated with the Earth's orbital motion. So one revolution in the orbit is annual. So 1 year man siya, madang annual aberration. We have also secular aberration. So it is due to the velocity of the solar system, but this is not observable. Next is ang parallax. Parallax is the displacement of the apparent object on the celestial sphere from its true position due to the shift of motion of position of the observer. The apparent change is relative position of stationary objects caused by change of viewing position. So ang iyahang link word ani class is change in viewing position. Pananaw nimo sa isa ka point is wala nag-move pero it's actually moving. So yung ana ang iyahang moral concept. So we have also diurnal parallax. This is due to the observer's change in position associated with the Earth's rotation. And we have again annual parallax for observer change in position associated with the Earth's orbital motion. Again, diurnal kay Earth's rotation kay 1 day, and annual is for orbital motion, which is 1 revolution 1 year. So this is an example of a parallax class. Like for example, sakay kag or let's say for example naka sa window sa bus and makita nimo na yan nga place no nga bukid or patag no, like sa may anang makarelate ang mga dili taga Butuan City no na magbiyahe pagdulong sa Busan Sur, Surigao Sur, Surigao Norte, and so on. So as you can see class, if you are focusing on the distant na object, like for example the dapit nga part no? Though nag-change ang imong position, kaya of course nagsakay man ka og sakyanan, tanawon nimo sa layo no? walay changes no? Pero actually it is really changing no? Kay ga-move good ka no? And dili gud na siya circular imong agihan, straight path gud na siya. So therefore ingani ang analogy sa parallax no? It's the change sa nagbase siya sa viewing position of the observer. Alright, so next is ang refraction. For refraction, as the light or the electromagnetic radiation passes through the atmosphere, being a medium of non-zero mass density, its path deviates from a straight line due to the effect of refraction. So again, murag na-discuss naman yun sa inyo no, mga science before no, nga pag ang isa ka object or the electromagnetic radiation kung moagi siya og another medium no, of substance no, so naay refraction, naay deviation between the direction of the electromagnetic radiation. It causes the apparent direction of the visible object to depart its true direction. So from light no, maagi siya sa atmosphere, which is another medium, so mo deviate siya no, naay refraction nga mahitabo. We have here two kinds of refraction, which is the atmospheric refraction, which is refers to the light reflected from the objects within the atmosphere. Within the atmosphere man gitawag siya atmospheric refraction. Astronomic refraction refers to the light coming from objects outside the atmosphere. So outer space na ni siya or sa outer na part sa atmosphere. So this is the illustration for refraction no? So na light path no? But kung what do you call this one, this is really the light path pero tungod kay miagi siya o the another medium which is Earth's atmosphere, so na deviation na may tabo no? Na deviation. So ingana or kung kani ang light path no? Mao ni ang nahitabo ng or no observers kani siya. So this is the apparent mo na ni karon ang direction no sa path sa sun or light from the sun instead of kani tungod kay niagi siya sa another medium which is ang Earth atmosphere. Alright, let's go to the celestial coordinate system. Balik ta ani nga figure. nakaagi naman siguro mani sa inyo ang astronomy na subject before or GE 101. If it is the Earth, so natay line, no, red line diha. Then we have the x-axis, or x-axis and z-axis, since kay 3-dimensional man. And let's say for example you are standing there, the part of the Earth, no? Ang nadapit sa may Europe, I guess, no? So kung imuha ng buhatan dira og axis, which is ang above nimo is zenith, di ba? And obos is ang nadir. And that green line is what we call the horizon. Horizon nga imong makita sa imong kung ka na-locate. So ang imong makita sa imong horizon is this one. Like for example, it's on where makita ang aurora borealis. So inga na imong makita didto sa kung asa ka nag-stand sa part sa Earth. So if you look up in the sky, it appears as if you are in the center of a vast crystal sphere with a fixed stars on its surface. So mo ni siya, no? Feeling nimo kung labi magsenti ka siya. Magsenti ka sa isa ka place, no? You are observing stars, yan, gusto mo lang mapag-isa. So paminaw nimo naa ka sa isa ka dako kaayo nga sphere. Kita nyo tanan ng stars and so on. So kana na natindog ka diha. Syagit ka kay broken hearted ka. Joke lang. No? So this sphere is what we call the celestial sphere. No? Celestial sphere ang tawag ana niya. Kanang nakamurag naka sa sulod sa isa ka sphere. So katong nga sphere nga imong giunahon na ang tawag ito niya ay celestial sphere. It has an infinite radius, so di siya fixed. We record positions of the stars by merely specifying angles only. So mao nang sa astronomy class, we are not dealing with the distance between the heavenly bodies or based from your location padulong sa isa ka celestial bodies. It's because infinite siya, no? Walay exact na measurement, no? So mao nang we are dealing na lang the position of the stars with respect to its angles. So that one, baliktaan nakakadiha no? Let's say for example, yan, nadaw ka sa center sa Earth, and yan na ang forma na nimo. Okay, nadaw ka sa center sa Earth, or you are at center of that sphere, no? Ang gitawag na tong celestial sphere. So we see only half of the sphere, no? Okay, may nag-imagine man ta nga nata sa center sa sphere. So ang ato lang pong makita is ang katunga lang sa sphere. Okay, since murag hemisphere kung magtuyok ta in 360 degrees atong location, ato makita is only half of those sphere. So the remaining half is hidden below. Okay, ang makita nimo ay mo imagine nga imo makita is ang hemisphere. So ang katunga sa imong sphere is nasa ilalo, no, below. So ang tawag adtong line kung asa ra taman imong makita, no, that's what we call horizon. The celestial sphere, no, balik tani nga figure from your previous subject in astronomy, no, in GE 101 or in astronomy subject, no. So sa new curriculum kay wala naman sila astronomy, so sa GE 101. So we have here a point, no, that right kanang red kani siya kani. Natay point diha So that is the Earth, no. Sa Earth na siya. Nang point diba tuldok ka pa dito sa universe. And we have here a circle, a great circle, no, nga nag tuyok sa iya. So kanang nga circle is what we call observer's horizon. Katong makita lang nato na makita nato. Next is another point sa taas, no? Kanang point sa taas is what we call zenith, or denoted as Z. Another point kung naay sa taas dapat naapuntay sa ubos. Tawagan na niya nga point is nadir or Z prime, denoted as nadir or Z prime. So we have this line of axis, no? Ay since ang Earth is tilt, no, dili siya perfectly nga ang North Pole is naa sa taas, like for example kung North Pole is north jud siya, when we say diri asa to ang okay, we all know nga from the vertical pala, no, dili siya kasabot nga si North Pole is naa siya sa vertical na directed, no, sa taas. So nagi na siya tilt, no, at some like around pilay tilt sa Earth, if I'm not mistaken 23 degrees, around 23 degrees. So correct me if I'm not mistaken. So kani siya nati axis, ang tawag na niya is ang where that is the polar axis. It's because diha man ato ang North Pole, adri atong, like for example if this is the Earth, this is the North Pole, and sa ubos na po niya is ang South Pole. So kung natay axis diha ay butang with respect to the celestial sphere, we have this polar axis ang tawag. Next is sa babaw sa polar axis natay point. Ang tawag ana niya is, kay since naman siya sa polar axis, tawag nato niya is North Celestial Pole. That is denoted as P. So abos pod kani, so kung natay North Celestial Pole, naapod tay South Celestial Pole, denoted as P prime. We have also this axis, no, nag-connect sa atong zenith ug sa nadir. So ang tawag ng axis is the observer's vertical, or ang tawag, or another term is vertical axis. So another great circle that connects, no, or dili siya nag-connect, 90 degrees of the polar axis. So ang tawagan niya nga circle is what we call celestial equator. Okay, since ang equator na to, kaya diba, mo na itong North Pole, mo na itong South Pole, tunga-tunga na niya is, mo na siya ang equator, diba, Earth's equator. So, i-extend na to siya into celestial sphere. That's what we call celestial equator. Another, kaning yellow, that connects all the point, no, manimuagi sa zenith, celestial North Pole, connects all the great circle, and also the zenith, or no, nadir, and the South Celestial Pole. Ang tawagan na niya class is observer's Meridian Circle. So, ano na si Nora Honor? Na siya ang star. Sige, si Nora Honor. Star for all season. Kung nadiha si star class, nga tong gi-observe, we have this great circle, no, from the zenith, connecting the star padulong sa nadir, no? Again, from zenith, no, padulong sa nadir nga circle. That's a great circle class, great circle nga muagi or mo connect pud siya sa stars nga gusto nato i-observe. So ang tawagan na niya nga circle is the vertical circle. Okay, since niagi man siya sa vertical axis kani. So, or ni-connect man siya sa vertical axis, so therefore ang tawagan na niya is vertical circle. Another circle is from the polar na pod, no? Polar axis, which is di-connect niya ang North Celestial Pole down to the South Celestial Pole nga muagi sa star nga atong gusto i-observe. So ang tawagan niya nga circle is the hour circle, nga niagi sa North Celestial Pole, South Celestial Pole, connecting the star. So before we are going to move on the how to locate the celestial bodies, so for complete definition of the parts of the celestial sphere, you can freely read, no, the chapters in astronomy in the GE 100, Higher Surveying Book of Laput or katong blue bitaw nga libro. So kung gusto mo og fully definition of those illustration nga ato ang gibuhat ganina of the parts of the celestial sphere, you can freely read those definition in Laput nga book. Alright, so let's go to the location of the celestial bodies, or how we can locate the location of the celestial bodies. So, the position of any celestial body may be defined by angular measurement from two planes. Dapat na ay duha ka plane nga references to locate the position of the celestial body at right angle to each other. So, katong duha ka plane dapat right angle siya, no? To each other and passing through the center of the sphere. And dapat moagi siya sa center sa sphere. Mo ni pasabot. Again, duha ka planes atong need, and dapat right angle to siya, and duha ka plane, and dapat moagi siya sa center sa sphere. First system on how to locate the celestial objects or celestial body is what we call horizon system. Alright, so to visualize the horizon coordinate system, so we have here a red dot. So that red dots represent the Earth, and we have here a great circle, and that great circle is what we call observer's meridian circle. The first plane in the horizon coordinate system is again the horizon or observer's horizon. So kanang line yung inyong makita kung kita sa inyong isa ka location, you are going to turn around 360 degrees, so that the line nga inyong makita, so that's the horizon. And let's consider nga ang North Pole is na dira nga part, and South Pole is na dira nga part. The next circle or the next plane, di ba on how to locate the celestial body is we need two planes, and dapat perpendicular sila to each other. So the second plane is the vertical circle. So kung saan mo tong vertical circle, so kung asa ang imong zenith, or say kung ano sa Earth, so diri ka nag-observe, ang imong zenith is nasa taas, nadir nimo nasa ubos. And vertical circle is from zenith to nadir, connecting the star or ang katong celestial body nga need nimo i-locate. So that's the vertical circle. So si vertical circle class, and si observer's horizon is 90 degrees. So yan, 90 degrees. Yan. So from south, ang iyang mga parameters is di ba mo unsa man nga angle nga mag-refer sa south or north. So alright, so that angle which is referred to south, it's because we are in the Philippines. So that angle is the azimuth. So that's the first parameter on the horizon coordinate system. And the other one, since nanatay sa ato ang x-axis or sa ato ang nanatay parameter sa horizon, observer's horizon, we need to have another parameter from the observers from vertical circle. So in the vertical circle plane, we have this angle from horizon padulong sa star. So this one, yan kana from horizon plane going to the star nga gusto na to siya i-locate, and that angle is what we call altitude. Alright. And ang iyahang complement, when you say complement, ang iyahang pag ato silang i-add, ang duha ka angles is 90 degrees. So ang complement sa altitude is what we call, di ba, kay since kay kani siya is zenith, which directly above sa imuha, so that's zenith. From zenith padulong sa star is what we call zenith distance. So the horizon system as a whole, the primary reference plane niya is ang horizon or the observer's horizon, and secondary reference is the vertical circles. The parameters is the altitude. This is the angle from the horizon going to star. So this is the parameter from horizon plane. sa horizon plane siya. Then si azimuth, di pala sa horizon, sa vertical circle. Si altitude is a vertical circle, and si azimuth is sa horizon plane. No? So when you say azimuth is the angular distance measured along the horizon from the observer's meridian to the vertical circle through the body. So mao to akong pasabot kanina sa atong i-discuss nga figure. Next is ang right ascension equatorial system. Balik ta ni, naka-tilt siya. It's because the Earth is naka-tilt. No? And we have here the star. No? So kani sa Earth, kani si north polar distance, north polar, celestial north pole, and kani sa ubos is ang celestial south pole. And this is your zenith, no? Like for example, nadiri ay imuhang point, nakadiri nagtindog. So directly above sa imuha is si zenith, and directly below sa imuha is si nadir. So first nga plane in the right ascension equatorial system is the equator, no? From the word itself sa to ang coordinate system, right ascension equatorial system. So we have the equator. No? Another plane is our circle. No? Si our circle is ang nag-connect sa north pole, the star or the location of the star padulong sa south pole. So that's our circle. And we have here, no, the projection of the star in the equatorial plane. So kana siya nga line kani. Ito lang i-project kung aha malocate si star, no, from the our circle. Right. So from equator, the first parameter is from the equator going to the location of the star. Yan, kana nga angle is what we call declination. So kani iyahang denotation, no? Murag S na basta Greek word, Greek letter na siya. So that's declination. And the complement of declination is what we called, so gikan sa north pole padulong sa star, so that's what we called polar distance. So what about the second coordinate for the right ascension equatorial system? The second coordinate or second parameter is defined by the hour angle taken from a first fixed point on the celestial equator. To visualize this one, so balik ta ani na figure. So we have here the star, the hour circle, and we have here katotong giingon na siya fixed point on the celestial equator. So unsa man ni siya nga fixed point? So that's what we call the kana nga symbol, no? Kana nga symbol is defined as the first point of Aries. Unsa man ning first point of Aries, sir? So this is the astrological symbol for the zodiac sign nga Aries, or ang kanang gintawag nato nga astronomical phenomenon. So at this point, no, kani nga point diri sa first point of Aries, diri may tabo ang vernal equinox, no? Vernal equinox. So when we say equinox, no, that's the astronomical phenomena, no, where ang night ug ang day is equal, no? Equinox. Natay duha klase nga equinox, which is ang vernal equinox ug ang autumnal equinox. Sakto ba ko? Yes, autumnal equinox. So ang kabaliktaran pod sa equinox or the other astronomical phenomena is what we call solstice, no? Solstices. So napoy duha klase ang solstice, natay gitawag nga winter solstice and napoy gitawag nga summer solstice. By the way, si vernal equinox is mahitabo ni siya every March 21 or 22 of the year, no? So ang this is the astronomical phenomena nga equal ang days ug night. So namagud na siya path sa sun diri nga nagana siyang forma. Yan, somewhat like ganyan, no? So from the vernal equinox, modagan dito padulong sa at this point, no? At this point, taas or mas dako ang iyahang differences, no, from the equator. So therefore, diri na pod mahitabo si summer solstice, where mahitabo ni siya every June 21 or 22 every year, no, summer solstice. Kasabot siya kay taas ang adlaw or taas ang oras sa adlaw compared sa gabi, no? Then tuyok na pud to siya diri padulong, no, sa murag atbang sa vernal equinox. Ito na dahil mahitabo si autumnal equinox. That's September, no? September 21 or 22. Yes, that's it. Then from that autumnal equinox, dagan na po siya dito padulong, where doon na po siya mahitabo, no? Doon na po nga point. At this some point na napoy mahitabo nga astronomical phenomena, which is ang gitawag na to og winter solstice. Winter solstice kabaliktaran sa summer solstice, no? Mas taas ang gabi compared sa adlaw, no? Or mas taas ang oras. Di siya mataas ang oras. Like for example ba nga kanang alas 5 pa lang ngit-ngit na kaayo, no? So mas more ang ngit-ngit compare sa hayag, no? Like alas 5 pa lang or 4 kapin pa mag-start na siya ngit-ngit, no? So that's the time nga may tabo ang winter solstice. Pag sa summer pod, kanang mabantayan nimo mga alas 4 sa kadlawon pahayag na. So that's the summer solstice. Padulong na siya mag-summer solstice. Again, so si first point of Aries is kato na siya nga makita si vernal equinox, na astronomical phenomena. Then we have here angle, no, from vernal equinox or kanang gitawag natong first point of Aries padulong sa star or ang location sa star. So kanang angle is what we called the right ascension angle, no? Right ascension. So it is measured counterclockwise from the first point of Aries padulong sa star. So ang tawagan niya is right ascension angle. So it is the angle taken counterclockwise along the celestial equator from the first point of Aries to the hour circle of the star. So the right ascension equatorial system, we have here the references, no? The equator and the hour circles. For parameters, we have declination, the angle from the equator going to star, and the second parameter is the right ascension, the angle taken counterclockwise along the celestial equator from the first point of Aries to the hour circle of the star. Next is ang hour angle system. Hour angle system, the position of the celestial body is based on the location of the observer. Again, take note, in the hour angle system, the position of the celestial body is based on the location of the observer. Kung asa ka nag-observe, asa imong location as a observer. Baliktaan ni, no, na figure, no, this is the equator, this is the earth, this is the celestial north pole, celestial south pole, zenith, and nadir. So we have here the star again, and this is the hour circle, the second reference, the second plane in the hour angle system. Kaya ang first plane is the equator man, and the second plane is the hour circle. So local hour angle in hour angle system pala is natay different kinds of angles. First is ang local hour angle. So local hour angle is the angle measured clockwise. Take note of this one kasi, clockwise from the upper branch of the meridian of observation to the meridian of the celestial body. When we say upper branch, kung asa imong location, kung asa ka na locate, no? Asa na locate ka nga nag-observe, no, og specific celestial body. Let's say the upper branch is right there. No? Naa ka diha nag-observe, no? At some point diri ang part sa what do you call this one? Earth man, no? So diri ka nga apart na nag-observe. This is your zenith, pero ang imuhang meridian, no, is naa diri nga part. Paana siya? Paana siya dira kaso? Paana? Yan. Mura siya og hour circle, pero in the part lang sa diri ang mura siya hour circle nga gi-project kung asa ang imuhang meridian, no? Meridian sa imuhang observation. When you say meridian, your longitude. No? For example, this is your upper branch or your meridian, kung asa ka na-locate. So, pasabot sa local R angle is the angle measured clockwise from the upper branch. So, pasabot diri sa imuhang meridian from the upper branch padulong daw sa celestial body or the meridian no, of the celestial body. So, kana siya nga angle. So, that is what we call local R angle. Next angle in the R angle system is the sidereal R angle system or is the SHA. Sidereal R angle is the angle measured clockwise, again clockwise from the meridian of the first point of Aries to the meridian of body. Haman imuhang meridian daw sa first point of Aries. So let's say mo na siya si first point of Aries nga tong gi-discuss kanina, no? Magbuhat ta og meridian niya, no? Mura pun siya upper branch, no? Pero meridian siya sa vernal equinox or sa first point of Aries. So ang pasabot niya, the angle measured clockwise from the meridian of the first point of Aries to the meridian of the celestial body. Clockwise. So gikan diri sa meridian of the first point of Aries, clockwise direction padulong sa meridian of the celestial body. Next is what we call the Greenwich R angle. Greenwich R angle or GHA, it's the angle measured clockwise from Greenwich meridian. So pasabot 0 meridian, no? Greenwich meridian to the meridian of the celestial body. Man makita si Greenwich meridian, sir. So let's say the Greenwich meridian is right there or the 0 meridian. From there padulong daw sa celestial body. So kana siya, no? Si Greenwich R angle kanang yellow. So that is the Greenwich R angle. Alright, to visualize more about the different angles in the R angle system, so we're going to put our point of perspective in the North Pole, no? Again, like for this one, no? Di na to ibutang atong perspective sa North Pole, no? Or celestial North Pole or the North Pole, no? North Pole para ang what do you call this one? Ato ang mas din na to siya ma-differentiate, no? Between these angles, no? The local R angle, sidereal R angle, Greenwich R angle. Again, looking from the North Pole, atong makita is ang equator, no? The equator. We have here ang kanino, since kay ang naman sa North Pole, isa ra ka point atong makita which is ang North Pole, and sa ubos niya napatanay point niya nag-overlap, muragi overlay man siya kay isa ra man ka point. Isa ra atong makita kay two-dimensional ra atong makita kay naman sa North Pole. So this is the poles, no, of the Earth. And this is your location kung asa ka na-locate, no, as a observer, no. Out from that, kung ato siyang meridian, so kana nga meridian is what we call the upper branch or the observer's meridian, no, kung asa ka na-locate. We have also here the first point of Aries, no, or what we call the vernal equinox. That's it. And we have also here the 0 meridian, which is the Greenwich meridian. And here are the star. Here is the star pala. Atong location, kung asa na-locate ang imong celestial body nga gusto i-locate. So the star. So this angle, no, again from the upper branch clockwise padulong sa meridian of the star. This is what we called the local R angle. Another angle, no, from first point of Aries or the vernal equinox padulong clockwise ang direction padulong sa meridian of the star. So that's what we called sidereal R angle. Another, no, from Greenwich meridian padulong sa meridian of the celestial body, that's what we called Greenwich R angle. We have also here, no, from the upper branch, no, padulong sa Greenwich Meridian or Greenwich Meridian and or more siya the difference between the Greenwich Meridian and the upper branch or your meridian na kung asa ka imong meridian as a observer. Again, observer's meridian padulong sa Greenwich Meridian. That's what we call the longitude of your place. Longitude of your place. And we have here also the only one nga counterclockwise na angle. So from first point of Aries, counterclockwise padulong sa meridian of your celestial body. So that's what we call the right ascension angle. So these are the scenario when we normal lang siya nga scenario kung how the movement of the sun and the stars at night. So first, in the morning, so mag-rise ang sun, gikan sa east padulong sa west. So paabot dia sa center, onto na siya, then going down padulong na mo hapon. So alright, kung maabot na siya dito sa ihang padulungan, syempre mo ngit-ngit na. And pag mo ngit-ngit na, of course na atay star, and kani pala nga part, kani siya nga figure is ang North Pole, So we are assuming nga atong North Pole is na dito, so therefore ang kani nga setting is naa siya sa somewhat like taas gamay sa equator, So muna tong North Pole and we have the star. So this star is a circumpolar star. Pag may tag circumpolar, magtuyok lang siya sa North Pole, magtuyok siya. Then so makita ninyo kanang mga circumpolar stars like Polaris, or the North Star. Di lang siya mag-revolve sa North Pole. And sa inyo makita, kung dili man gid nato makita directly si Polaris, So ingan yang mahitabo kung if ever dool ta sa North Pole and makita na to si Polaris, then si Polaris is a circumpolar star. And we have also another star, balik na po si Nora Honor, the star for all seasons. So kung mag-revolve na sila kung circumpolar stars, example sa circumpolar stars are Polaris and other stars nga dool lang sa North Pole, Okay, si Polaris is approximately 1 degree ang iyang difference from the North Pole. So again, circumpolar stars, sige na siyang tuyok. And kung makita ninyo kung dool na mo sa may North Pole, dili gid na siya mawala sa inyong sky at night. Diya gid na siya permanente magtuyo. Kaya sa kanang nabantay na to, di ba sa Philippine settings na kung if ever natin makita nga star, mura jud mo silag sun nga pag mga around 8 PM, so makita na to siya sa sky. Then pag around mga 4 PM, so mawala na siya, It's because nagtuyok man ta, so mawala ang katong star sa ato ang sky. Kaya nag-revolve man ta or nag-rotate man ta. So in the Philippine setting, let's say this is the North Pole, and we have here the Polaris. Si Polaris, pag naa siya sa taas sa North Pole, itawag na siya upper culmination. Hangtod na pamatulong na siya dito sa dira. So at that point, ang tawag ang Polaris is na siya sa western elongation, and pag mapadulong na siya sa ubos south of the Polaris is what we call lower culmination, and pag moabot siya sa east, so that's what we call eastern elongation. So again, ako lang nang gi-emphasize class kay it's because di ba we are talking about the stars or position of the stars. One of the important stars manggod nga atong kinanamistudihan is si Polaris. Mo nang ako siyang gi-appeal. So balik din siya sa iyang upper culmination. And wala siya yung path. So that's what we call circumpolar stars. And one example of circumpolar star is si Polaris. Next is the gravity field related reference systems. The significance of the external gravity field of the Earth in the Geodesy may be described comprehensively as follows. First, is the external gravity field in the reference system for the overwhelming part of the measured quantities in geodesy. The field must be known in order to reduce the quantities in geometrically defined systems, and if the distribution of gravity values on the surface of the Earth is known, then the combination of the geodetic measurements, the shape of its surface may be determined. And the most important reference surface for height measurements is the geoid. So, muna akong i-discuss, no? Katong when we say horizontal coordinates and horizontal measurements ang ato ang kuhaon, so the suitable surface, no, or shape of this surface is the ellipsoid, no? While the most important reference surface for height measurements is the geoid, no? This is the idealized ocean surface, is a level surface for gravity field, no? Muna siya sa geoid. The analysis of the external gravity field yields information on the structures and characteristics of the interior of the Earth, no? In making the corresponding gravity field parameters which is available, geodesy becomes an auxiliary science of geophysics. So here is the illustration that shows the different surfaces of the Earth, or how to approximate the surface of the Earth. So we have the surface here, the terrain, the geoid, and the ellipsoid. So here is another representation, no? So the dark blue, or the blue-green, that represents the Earth's surface or the terrain, and we have also the geoid. So the geoid pala is the sea surface and its extension towards the continents or the land parts, and si ellipsoid siya ang nag-approximate sa geoid na surface. And we have also here, I am going to introduce now the different heights, no, to have the relationship between these surfaces. So para mas madali na to siya masabtan and the relationship between these surfaces, we have these heights or formula. First is the orthometric height. So kanang h nga dako diha is denoted by big H of a point is a distance along the plumb line from the point to the geoid. So when we say plumb line, it is the direction parallel to the gravity towards the center of the Earth, padulong sa center sa Earth. So kung asa padulong ang direction sa imong gravity, dito pod ang plumb line. And again, orthometric height is distance along plumb line from the point, or kung asa ka nagtindog sa Earth's surface, to the geoid, or kanang dark blue nga color sa geoid, no? So denoted by big H. And geoid, again, we're going to define, it is the imaginary surface that coincides the mean sea level in the ocean and its extension through the continents. So from the sea surface, extended padulong sa continents or landforms. We have also here ellipsoidal height, or kanang H nga gamay. So ellipsoidal height of a point on the Earth's surface is the distance from the point, or kung asa ka nagtindog, padulong sa ellipsoid surface. Orthometric height from the point to the geoid, and ellipsoidal height from the point to the ellipsoid. Again, si ellipsoidal height, dito gyapon siya, ang direction gyapon niya is same sa imuhang kung asa padulong ang imong gravity towards the Earth. Again, so naman the definition sa plumb line. Plumb line is a line that corresponds to the direction of the gravity. So, di ba, muna kung diyan ka ganina. At a point on the Earth's surface, or also, it is the line along which an object will fall when dropped. Padulong man siya sa center of the gravity sa Earth. And we have also here another illustration. So, kung mag-meet si geoid, ellipsoid, ug ang terrain, so mao ni iyang mahimong illustration. So we have here normal to the geoid. Normal to the geoid is 90 degrees from the point with respect to the surface of the geoid. And we have also normal to the ellipsoid. So at that point, 90 degrees with respect to the surface ellipsoid. And that angle, no, kanang angle nga na-create between the normal to the geoid and normal to the ellipsoid is what we call the deflection of the vertical. So let's define geoid again. Geoid is the equipotential surface of the Earth at mean sea level, or a level which oceans find a state of equilibrium. Diba? Ang pagkuha sa mean sea level is dili siya it's a long process, no? So in fact dapat 19 years, no, continuous observation para lang makakuha ka og mean sea level. And from that mean sea level, i-extend na nimo padulong sa imuha sa landforms, then mo na siya ang ma-form nga geoid. So geoid is not perfectly regular due to the local anomalies in the gravitational field caused by non-homogeneous nature of the surface and substrata. So as you can see in the picture, no, dili gid siya regular, okay? Mura siya og kanang bato, no? Wala siya exact na shape. That's geoid. Another picture that shows the geoid. And ellipsoid, it is the simplest analytical figure to closely approximate the surface of the Earth, or the geoid. No, since kinatay geoid, ang katong form, no, nga nabuo sa geoid, i-approximate na siya para simpler ang ato ang formula, and of course simpler ang ato ang pag-derive of formula to get or to determine the different aspects. So analytical that approximates the surface of the Earth, or the geoid. An ellipsoid is simply the meridian ellipse that is rotated about its minor axis. So meridian ellipse, it's because in meridian, no, meridian nga meridian, in the meridian siya nga magtuyok, kay balimrag ang iyang axis is naa sa meridian, so nangitawag siya o meridian ellipse. Minor axis, mubo man siya, no? Ang mubo nga part, dili tong taas. So the local relationship between the geoid and the ellipsoid, so mao ni siya ang formula nga i-introduce kaning si diba nato ato ning gi-define ganina nga kani si H is mao ni siya ang ellipsoidal height. So that's mean ellipsoidal height is the height of the Earth's surface above or below the ellipsoid. So kung mao ni si ellipsoid, no, from the Earth's ellipsoidal height is the height from the Earth's surface above or below. So kung mao ni ang surface, no, Earth's surface, ay mo man terrain, no, mao ni ang ato ang usual nga terrain sa ato ang surface sa Earth, no. From that point, for example this one, so from this point padulong daw sa ellipsoid, mao na siya si ellipsoidal height. So ni si H, and karon si H na pod is si orthometric height, no. Orthometric height is the distance between the Earth's surface and the geoid. So from balik ta diri ang point kani, so from that padulong daw sa geoid kaning blue, no, si geoid, which is normal daw ana nga point. So kung normal pasabot 90 degrees again, so magbuhat tangent line diha 90 degrees. So kani nga line mo ni siya ang normal line sa kani nga point. So mo coincide siya ana nga line. So from that point padulong sa geoid, so mo na siya si orthometric height. And si N is the geoidal undulation. It is the distance between the ellipsoid and the geoid. So ang kaning example, kaning gamay nga distance sa blue ug sa red, mao na siya ang geoidal undulation from geoid to ellipsoid. So from that relationship makakam up ta ani nga formula na si HDI, which is ellipsoidal height, is equals to orthometric height plus geoidal undulation. And I guess and I hope nga nasabtan ninyo ni before pa lang sa inyong geometric geodesy. So some notes for the review of geodesy. The physical shape of the Earth is closely approximated by mathematical surface of the ellipsoid. Physical surface, from wala akong i-discuss last time, na natay surface, no? Tapos i-approximate din siya mathematically, no? Mathematically to the mathematical shape of the earth, which is the geoid. And from the geoid, ana din siya ellipsoid para mo fit in ana nga geoid. The ellipsoidal surface is smooth and convenient for mathematical operations. So let's agree with that. It's because geoid is irregular, diba? Ito ang i-discuss a while ago. And this is the reason why the ellipsoid is widely used as a reference surface for horizontal coordinates in geodetic networks. No? Ay since smooth man siya and na siya geometric relationship, so gamiton lang na siya for horizontal coordinates in geodetic networks. Take note ha, horizontal coordinates. And the ellipsoid is not suitable as the reference surface for the vertical coordinates such as orthometric heights or elevation. As we all know nga si ellipsoid is ang smooth, no? Smooth siya nga surface. And napod siya mga mathematical formulas and parameters to determine the coordinates, no? Coordinates of that the horizontal coordinates of that point, specific point. So dili siya pwede gamiton sa vertical coordinates or kanang height, no? Kaya we all know nga ang surface sa earth is irregular, no? Mubaba siya sa ellipsoid, napo usay mo saka siya sa ellipsoid. So ang gamiton na niya nga surface is ang geoid, no? So a geoid is used instead in the vertical coordinates. And when using a geoid as a reference surface for orthometric heights, it is evident that the geoid undulation must be known. Geoid undulation kay nga naman, from this relationship kaning si h is equals to h plus n, h plus n. So from the surface of the earth, kay kuan man siya kanang irregular man siya, so makakuha ta og ellipsoidal height, no? Ellipsoidal height. And gusto na to kuhaon si orthometric height, no? Or ang kanang ginatawag na to og elevation. So makakuha tag ellipsoidal height, no, from the point of the surface of the earth padulong sa ellipsoid. Ang ato lang karon is ang kaning n. So aha man ni pangitaon si n, si geoid undulation. Dapat mahibaw-an ni siya. Asa man ni siya pangitaon, sir? So how do we determine n, or the geoid undulation or geodesy separation, is the use of the geopotential or gravitational models. So for example kani siya from the EGM 96 geoid models in meters, no? So makita ninyo na, by the way, kani si n, no, mo ni siya ang separation or the distance between the geoid and the ellipsoid. So as you all know, kanang red na part, grabe ka red na part, 80 meters ang ilahang difference, no, between the ellipsoid and geoid. And kaning si blue, muna siya ang pinaka lowest pod na figure, which is negative 100. So from that makakuha na to dayon si orthometric heights. So example of this geopotential and or gravitational models is kaning gitawag na to si EGM 96, no, kani siya ang model. And napot na gitawag nga EGM 2008. So makuha ninyo na siya through their websites. So here is the Philippine Geoid model or PGM 2006. So maupod ni ang geoid model sa Philippines, no? So this is from NAMRIA, by the way. So makakuha mo ani niya via this website. So values are the geoid heights or n reference with the WGS ellipsoid. So ellipsoid ni siya sa WGS kay since WGS is the worldwide man siya na adapted na ellipsoid. Next is we are going to discuss the terrestrial reference system. So terrestrial reference systems, in terrestrial reference systems, the geodetic control at local, regional, and national and international levels has been revolutionized by the advent of satellite systems that provide accurate positioning capability to terrestrial observation at all scales, where of course the Global Positioning System or GPS had the most significant impact. So ang mga controls no in the local, for example sa Philippines or sa Philippines is kanang mga kung yung tag local class is kanang mga local control na kamo ang nag-establish no, dili siya pero base siya sa PRS 92 but wala siya gi-register nimo wala siya na-register in the NAMRIA or the NAR. Well, ang kaning while kaning regional level is kaning mga gipangtukod sa regional composite team no sa DNR no. And for national we have NAMRIA nga gipang establish, and for international levels is katong mga control no for densification of the reference systems worldwide. And we are using Global Positioning System or the GPS had the most significant impact no in getting the accurate coordinates of the geodetic control. So in the Philippines, we have geographic position and plane coordinates or GPPC no. So nahati ni siya sa duha which is naka WGS 84 or World Geodetic System of 1984 or WGS 84. And kani pod siya is Local Plane Coordinate System or LPCS. Mo na siya ang mga naka-northings, naka-eastings, based siya sa zoning no sa UTM, no naka-UTM ni siya. And we have also PRS 1992 or Philippine Reference Systems, which is gikan siya sa WGS 84 nga ellipsoid no? And ang iyang output is geographic coordinates kanang ato ang makita nga latitude and longitude sa isa ka muhon or monument, and sa PICAS pod from Philippine Plane Coordinate System. So this is local coordinate system established in the Philippines, and ang iyang output is grid coordinates kanang ato ang makita no nga northings, eastings no naka meters ang iyang coordinates, while diriya sa geographic coordinates is naka latitude and longitude. So let us recall first the ellipsoid as a geodetic earth model. When we say geodetic earth model, mao ni siya ang gigamit no as reference for the actual surface of the external gravity field of the earth, and it provides a good fit to the geoid and the gravity field. So diba sa atong mga previous topics no, out from the terrain or surface of the earth, so approximate siya sa geoid using sa katong high dense or low dense ng mga areas, but irregularly shaped pa siya. So mo to sa geoid, and out from that irregular surface like for example gikuha na pud siya og good fit no para mahibaw-an kung para mas ma-simplify ang shape sa earth. Therefore si geodetic earth model, which is ellipse, so gi-simplify siya para mas masabtan or mas dali makalculate ang mga positions sa some point of the earth. This model is simple and serve as the standard for application not only in geodesy and cartography but also in astronomy and geophysics. The geodetic earth model is the ellipse. For ellipsoidal coordinate system, we have ellipsoidal or geodetic latitude no kani siya. This is denotated as this Greek letter no? Or also pwede pud siya kani. And we have ellipsoidal or geodetic longitude denoted as lambda. For geodetic latitude atong i-define no, like for example at this point naa kadira nagtindog no? So mao ni siya ang ato ang geodetic latitude kani nga part no? So it is the angle measured in the meridian plane between the equatorial plane or the XY plane of the ellipsoid and the surface normal to P. So kanina na ay tangent diya nga line normal so 90 degrees. This one kani nga radius so gikan sa equatorial plane or XY plane padulong sa radius sa point P no? Which is normal to point P. We have also geodetic longitude or lambda of point P. It is the angle measured in the equatorial plane no? Diri siya gi-measure sa ato ang plane sa equatorial dira. and it is measured in the equatorial plane between 0 meridian, which is the x-axis, atong nadiri sa atong figure, dinote ni siya as kani nga meridian is 0 kani, and the meridian of the plane P. So gikan dira nga plane from the di ba sa equatorial plane man siya, no, i-measure. So gikan ani nga meridian, which is kani, padulong sa meridian sa inyong point. So kani, this is now the geodetic longitude. So the ellipsoidal meridian plane is formed by the surface normal and the z-axis. The 0 meridian of the plane usually chosen as the meridian plane passing through the Greenwich. So that's according to Kersley 1984. So please take note, no, again and again, that pag moingon ta og geodetic latitude, it is always, no, dapat sa geodetic latitude is 90 degrees north or south lagi siya, no? 0 to 90 north and 0 to 90 south. And for longitude, that's 0 to 180 degrees east and 0 to 180 degrees west, no? So mao na siya ang kinahanglan, importante masabtan. So let's talk about local plane coordinate system. So when we say local plane coordinate system, so it is a floating coordinate system which uses a plane surface having a floating origin. So sa unang panahon ingani ang survey class, no, they are using local coordinates, no. Usually BLLM number 1 of cadastral case or project, no, floating murag mo to kung gigagani na murag reference frame siya, pero wala siya kabalo kung asa niya i-tie up, no? Murag like okay, mag-survey ko sa isa ka area, then mag-establish ko isa ka point diha, ako na siyang assign na og coordinate na 20,000, no? 20,000, 20,000. Di ba, according sa definition, a floating coordinate system which uses a plane surface having a floating origin, no? Assigning and 20,000 as its northing and easting respectively. So kung ngayon ko sa unang panahon, ingani ang gina-adapt kung wala pa si PRS. No nga, na isa ka point, no, mo na akong origin, then mo na iyang coordinates 20,000, 20,000, 20,000 for northings and 20,000 for eastings, no, respectively. And in this coordinate system, all cadastral surveys and isolated surveys done before 1965. So before 1965, ang ilang gigamit nga coordinate system is kani si local plane coordinate system. So 1965 pataas, so line na pod nga coordinate system. So here it comes, no, after 1965, si Philippine Plane Coordinate System Transverse Mercator or si PPCS-TM Luzon 1911. So again, before 1965, all the cadastral surveys used is the local plane coordinate system. And since it is floating coordinate system, connecting cadastral survey outputs of various municipality became a problem. Of course, no? Kay wala man siya gitay-apan, no? Dili man siya unified ang iyahang coordinates. Okay? Basta na lang pag moingon ko lahi-lahi nga engineer, labi naglahi-lahi nga engineer ang mo survey, tapos layo na ang katong isa ka fixed point nga iyahang gisurveyhan before. So every survey niya na siya local na type point, which is 20,000, 20,000. So out of that, magka-problema jud kung unsaon pag consolidate ang all nga data, all cadastral data, no, or all cadastral survey outputs, no, labi na kay pag mayon tag cadastral municipality wide na siya, no? And to provide a unified coordinate system, mao ni gi-introduce si PPCS-TM Luzon 1911. I-establish ni siya. It allowed all the connection of the different cadastral and isolated surveys in the Philippines. No? After sa 1965, gi-unified na siya, no? Na gi-connect na tanan-tanan nga survey output sa cadastral para unified na, no? Dili na dapat magbalikod pa tong 20,000, 20,000 nga or local, no, coordinates. And pursuant to Land Circular number 64 or LC64, that is dated June 30, 1965, PPCS-TM Luzon 1911 was adopted as the Philippine Coordinate System sa Philippines. This coordinate system was established from the combined astronomic and triangulation surveys in the Philippines. No? So pag-establish ani nga mga control po ang pag-establish sa mga reference frames ani or control points ani nga system is through astronomic observation or kanang gitawag natong stellar and solar observations and triangulation surveys in the Philippines. It provided grid and geographic coordinates based on the Clark spheroid of 1866, no? Or Clark ellipsoid na gi-adapt sa Philippines, which is Clark 1866 parameters, and the projection nga transverse Mercator. So mauna siyang naay transverse Mercator sa iyang system na pangalan. And here it comes, no? Sunod ni PPCS-TM Luzon 1911, niabot na pud ni si PPCS, no? TM Philippine Reference System of 1992. So in Philippine Reference System of 1992, it is a homogeneous national network of geodetic control points or GCPs, which is marked by survey monuments or mohon. That was being established using global positioning systems or GPS technology. So basically, ang kaning si PRS-92 is iharang gi-modify si Luzon datum 1911 mga mohons. But in PRS-1992 is nigamit na siya og global positioning system or GPS. By virtue of AO45, it became the standard reference system for all surveying and mapping activities in the Philippines. The order also mandated that all new surveys and maps shall be referred to a new network, and the old network surveys shall be integrated into it. So, muna ni ang gi-adapt sa Philippines until now, no? Si PPCS, TM, PRS 92. So, 4 plane coordinates ni ka sa kanang X and Y or northings and eastings. So, ang katong mga bagong surveys dapat adapted na siya ani, and katong mga old surveys dapat i-integrate siya. So, mo na akong gidiscuss sa ganina, no? Nga si PPCS TM or PRS-92 is the modified version of PPCS TM Luzon 1911, and it was established through GPS surveys all over the country. So, who will execute or who will implement this system, no, or reference system in the Philippines? So first, we have this mother agency, which is the NAMRIA, or the National Mapping and Resource Information Authority, no? So, or NAMRIA. So, sila ang mag-establish sa first and second order control points. So, class basin mangutan na mo sa ning first and second order control points. Makita nato ni sa to ang manual, no? Geodetic Engineers Manual, no? Which is the DAW 1998-12, naapod siya sa DAW 2007-29 o sa DMC 2010-13. And the DNR Regional Composite Team or Composite Survey Team or RCST, sila na pod ang mag-establish sa third and fourth and other lower order control points, which is one na yung ginagamit for land surveys, property surveys, and other all kinds of surveys, basta pasok lang sa lower order ng control points. But for the first and second order, si NAMRIA dyan siya. Next is the geographic to grid conversion. So basically, ang purpose lang ani niya class, kay when we say geographic, diba, is naka-ellipsoidal ni siya, which is latitude and longitude. And pag winta grid is naka-northings or easting. So naka-meters ang iyang units ani class. The following formulas are used in transforming a given set of geographic, which is naka-latitude and longitude coordinates, to its corresponding grid, which is northings and eastings coordinates, where N and E are the northing and eastings respectively. So the formula is kani, northings is equals to Roman numeral 1 plus Roman numeral 2p squared plus Roman numeral 3p to the fourth, and we have E prime, no? E prime is equal to Roman numeral 4p plus Roman numeral 5p cubed plus Roman numeral 6p to the 5. And to get these things, atong adan ang nakuha na itong value sa E prime of 500,000. And where p is equal to 0.001 change in longitude nga naka-express into seconds. And for 5 to change to get the change in longitude, ang iyang formula is longitude nga given, no, sa problem minus longitude of the central meridian. And the values of these Roman numerals are interpolated or pwede po siya makuha diretso no, sa table 1 of the Technical Bulletin number 26 or the Philippine Transverse Mercator Grid Tables. So, ma-research niyo sa class sa internet, ma-download na ninyo. Next is the grid to geographic conversion. In converting PPCS, TM, PRS 92 grid coordinates, which is naka-northings and eastings, to their corresponding geographic, which is latitude and longitude coordinates, by using the table 2 of Technical Bulletin number 26, the following formulas are to be used. No? Muna siya ang formula. So, to get the, basically class, ang ihalang aning purpose is, i-convert na po nato, baliktad na siya sa to ang gibuhat atong sa first slide, or last na to ang discuss. No? Which is, from northings to eastings, ato siyang i-convert into geographic, which is latitude and longitude. To get that, no, this is the formula. So, latitude is equals to latitude prime. No, kani si latitude prime plus, makuha na to ni siya sa table 2 of Technical Bulletin number 26 using interpolation. Minus Roman numeral 7q squared plus Roman numeral 8 are 8q to the 4th. No? And kani nga mga values, so 7q squared plus 8q to the 4th must be in terms of seconds. No? Naka-seconds dapat na siya. So next is the change in longitude nga naka-seconds po lang iyang format. So we can get that using this formula nga Roman numeral 9q minus Roman numeral 10q to the q raised to the power of 3 plus Roman numeral 11q raised to the power of 5. To get the longitude, we have this formula, change in longitude of central meridian, no? Same lagya po ni pagkuha sa katong previous na to mga previous slide, no, sa pagkuha sa change in central meridian. Plus minus, no? Again, plus minus siya kay kung negative ang answer, minus. Pag positive ang answer, plus. Plus minus change in longitude nga naka-seconds, which is ang output aning sa equation number 7. Where q is equals to 0.000001 e prime. No? And to get this e prime is we need to have this formula. No? Eastings, which is given, eastings minus 500,000. No? Eastings minus 500,000. Again, the values of the Roman numerals and the latitude prime can be obtained by interpolation from the table 2 of Technical Bulletin number 26. So for international terrestrial reference system, the international efforts to define the terrestrial system can be traced back to the turn of 1900s, no? When the International Latitude Services or ILS, this was established in 1899 by the International Association of Geodesy or IAG. So, organize the observations of astronomic latitude in order to detect and monitor the motion of the pole. Basically, nag-start ni siya kay they are trying to explore or observe the motions of the pole. The ILS was reorganized into International Polar Motion Services or IPMS in 1962 by resolution of the International Astronomical Union or IAU, and the IPMS officially continued the work of the ILS. We have also Rapid Latitude Services or RLS of the Bureau International d'Hyuri or BIH in Paris, France, was established in 1955. Again by the International Astronomic Union or IAU, and predicted the coordinates of the instantaneous pole and serve as the primarily to help the timekeeping work of the BIH. And in addition, the US Navy and the Defense Mapping Agency published a polar motion results out from the observations. Based on the latest observing technology such as lunar laser ranging or LLR and the very long baseline interferometry or VLBI. In 1960, it was decided at the General Assembly of the International Union of Geodesy and Geophysics. So na-change na siya ang name, no? And nag-decide sila na i-adapt nila ang terrestrial pole output from the previous, the average of the true celestial pole during the period of 1900 to 1905. This average was named the Conventional International Origin, or CIO, starting in 1968. However, from 1950s until 1980s, the BIH monitored the variation in longitudes due to polar motion of many observatories, and a mean Greenwich meridian was defined. So, diri na nga time nga na-establish na si Greenwich meridian, which is 0. Based on the average of 0 meridians as implied in the variation corrected longitudes of these observatories. So, those time na determine na nila ang 0 meridian, which is naa sa Greenwich, England. And at bang sa prime meridian, which is ang 180 degrees, ang tawag na niya is international dateline. Sabot ana nga pag muagi ka na nga meridian, mag-change na ang imuhang day, more +1 na ang imuhang day. So when you say international dateline, so it start at 180 degrees. This is also where the new day or the new date begins. For example, in 12 midnight. In the Philippines, di ba, pag mula pa sa tao 12 midnight, so that's the time na mag +1 ta sa atong day. So international dateline is the opposite of the prime meridian, which is 0 degrees longitude in the Greenwich. And there is a difference of 12 hours between prime meridian and 0 degrees of the international dateline. So 180 degrees longitude. Okay, since 12 degrees is equal to 1 hour, 12 degrees ba? 15 rather. 15 degrees is equal to 1 hour. So, itong nang i-divide ang 180 into 15. So, mahimo na siyang 12 hours. Manang ilang difference is 12 hours. So, for International Terrestrial Reference System in 1988, the functions of monitoring of the CIO and the reference meridian were turned over the newly established International Earth Rotation Services, or IERS, thus replacing the BIH and the IPMS as service organizations. So, the IERS renamed in 2003 to International Earth Rotation and Reference System Services. So, retaining gyapon ang iyahang acronym, which is IERS. So, ang responsible na ni siya for defining defining and realizing both the International Terrestrial System and International Celestial Reference System. So, mas comprehensive na ang ilahang tasks and responsibilities. Kay apila ang celestial o ang terrestrial. So, the IERS, International Terrestrial Reference System, is defined by these following conventions. Kay sa unang panahon, para mas ma-define nila or masabutan nila ang mga origin, for example, ang mga parameters, so dapat they need to convene through conventions. And out from that conventions, mo ning ilahang na-define. The origin is geocentric daw. That is, pag maintag geocentric, ang origin is naa sa center of mass of the Earth, including the mass of the oceans and atmosphere. But nowadays, because of the capability to detect the small centimeter level variations due to terrestrial mass redistribution, the origin is defined as the average location of the center of mass and referred to some reference epoch. And the IERS, International Reference System, is defined by the following conventions. Again, origin. This is realized by observing the motion of the artificial satellites as well as the moon using ranging techniques, where the most precise method are based on laser ranging, although microwave ranging using GPS satellites has now also proved the yield of good accuracy. So, dapat mahibaw na to kung asa ang origin. In the Philippines, so this is the origin, the origin of the reference system of the Philippines. This is at Station Balanacan, which was located in Mount Mugpog, Marinduque Province. So, ingani ang forma no, sa origin, or basta nakita na mo sa Facebook or sa internet about anang the station Balanacan. And next is the scale. No? The scale is defined by the speed of light in vacuum and the time interval corresponding to the time 1 second within the theory of general relativity and in the local Earth frames. The scale is realized by adapted constant for speed of light and the definition of the second as given by BIPM or the System International or SI, second in the geocentric frame within the context of the theory of general relativity. Next is the orientation. So, orientation is defined by the direction of the CIO and the reference meridian as given for 1984 by BIH. Since it is now well established at the Earth's crust and is divided into plates that exhibit tectonic motion, it is further stipulated that the time of evolution of the orientation of the reference system has no residual global rotation with respect to the crust. Another one for orientation of the ITRS is realized through the coordinates of points that is referred by the CIO or IRP and the mean Greenwich meridian. Now, ang tawag na sa iya is International Reference Meridian or IRM. And it is maintained by the IERS using Earth orientation parameters that describe the polar of spin axis relative to the crust and orientation with respect to the celestial sphere that was affected by precision and notation. So, si IERS ang responsible to have a monitoring on the polar axis or polar spin axis or the change in orientation of the pole, and that is the precision and for notation. So ako na nag-discuss no sa ato ang previous slides. So the Philippine Reference System of 1992 or PRS92 datum. So formerly it was Luzon datum of 1911. So ingani ang forma no, sa Station Balanacan. So this is where the mapping and surveying coordinates was referred in the Philippines. Located in Mount Mugpog, Marinduque Province. So sa PRS 92 datum is referred by the geographic coordinates of triangulation of the coast and geodetic surveys known as Station Balanacan. So, mao niyang parameters, ang spheroid na gigamit is si Clark 1866 and the geoid spheroid separation of 0.34 meters. This is based on DENR 2007-29. So, we have here the coordinates. This is the official coordinates of Station Balanacan. We have the latitude of north. We have the latitude of north 13 degrees 33 minutes and 41 seconds. And for longitude, east 121 degrees 52 minutes and 03 seconds. So this was the official coordinates gi-adapt sa Station Balanacan. More about PRS-92. So PRS-92 or the Philippine Reference System of 1992 is a homogeneous national network of geodetic control points or GCP marked by survey monuments or mohons that has been established using GPS or Global Positioning System technology. By virtue of EO 45 dated January 5, 1992, PRS-92 became the standard reference system for all the surveying and mapping activities in the Philippines. And the order also mandated that all new surveys and maps shall be referred to the new network and all old surveys shall be integrated into it.